Hey everybody, Ms. Dietrich here helping you on lesson 10.8, problem solving, changing dimensions. We're going to look at the following problem. Jason has created a 3-inch by 4-inch rectangular design to be made into mouse pads. To manufacture the pads, the dimensions will be multiplied by 2 or 3. How will the area of the design be affected? Alright, what I've done at the bottom here is here's the original shape right here, which is a 4 by 3. And we're going to multiply it by 2 first to make the bigger shape. If we do 3 times 2, we're going to get 6, and if we do 4 times 2, we're going to get 8. If we take the original shape and multiply the dimensions by 3, 3 times 3 would give you 9, 4 times 3 would give you 12. So they want to know how will the area of the design be affected, so that's what we're going to explore. Let's take a look at the area of the first shape. If we were going to go ahead and find the area of that, we would multiply base times height, or 3 times 4, and get 12 square inches. Let's take a look at the one that was doubled, where the dimensions were doubled. Base times height, 8 times 6, we get 48 square inches. Now what you really need to think about is what do you need to do to the 12 to get 48? And the answer to that would be you would be multiplying this by 4. Now I want to point something out to you. You know how we change the dimensions by multiplying it by 2? Well, did you know that this 4 is the result of squaring this? 2 squared would be 4. So that's kind of a nice little shortcut if you understand it. Let's see how it might work with the larger shape and the multiplying by 3. Now remember, the original area was 12 square inches. If we found the area of the larger one that was multiplied by 3 for both sides, we would get 108 square inches. Now let's ask ourselves, what would we have to do to the 12 to get this number, Multiply it by what? And wouldn't that multiplier be by 9? Isn't 12 times 9 108? Now it's not a coincidence that if I were to square these two things, I would get 9. So in other words, the area is affected by being multiplied by 9. Let's take a look at some more complex problems. In this example, we're looking at a triangle, and they're talking about changing the dimensions by multiplying each side by a half and then by a quarter. Now remember, multiplying by a half is the same as dividing by 2. So if we take this 6 and we take half of it, we would get 3. If we did the 16 divided by 2, we would get 8. So let's take a look at how the area is affected. If we found the area, if we finish this, half of the base times height, half of 6 would be 3, or we could do the half of 16 and get 8 and then multiply it by the 6 and get 48 square centimeters. And let's do this one. Half of 8 is 4, and 4 times 3 is 12. 12 square centimeters. Now remember, we took a half. We did this times this to get that. And we did the same thing here. This times a half to get that. Now if we squared 1/2, wouldn't that equal 1/4? Because 1/2 times 1/2 is 1/4. Now let's look at the areas. 48, what would we have to do to get 12? Wouldn't we have to multiply it by 1/4 to get that? So the shortcut is to square whatever you're doing here to get how the area is going to be affected. So if we take that same strategy and kind of think of what would the answer be here, we don't even necessarily have to finish this, and we could do 2 times this would be equal to 3/2, and then that would cancel out, and that would be equal to 3. But let's think about this. 48 what equals 3? 48 what equals 3? Well, remember, we took a fourth. So if we did 1/4 times 1/4, that's going to be 1/16. Or divide by 16, it's the same thing. Is 48 divided by 16 going to give you this 3? It sure is. Alright, so in review, just square the value to get how the overall area is affected.